let's go through the documentation a bit, because we will be just following, as the first example, we would be following the unit example. So we'll start off with a simple vision model, and then we can continue with the rest of the examples. So again, I cannot stress enough. Please follow the documentation website on the docs.alcf.anl.gov. You have the AI testbed. Specifically here, we're dealing with the SambaNova system. So if you can navigate through this website, you have the SambaNova contents over here. And then, of course, getting started will give you the information as to how to log in to the systems. Log in through first the login node, and then from there SSH to one of these compute nodes. So I cannot stress enough for folks to try to kind of diversify when you try to log in and initiate your scripts on different compute nodes. Don't use R1, H1 as the default one, just for the reason that if you are not careful in putting your scripts correctly, and you always use the default node, then it will try to pick, and sometimes you will have a lot of users are using at the same time. They might be your jobs might get queued up. So always please try to diversify the compute node on which you're going to initiate your script. So having said that, let's dive in to the examples. I see there is some things in the chat. Okay. So I hope everyone has the link to the documentation. So let's get started. So for unit, so the actual scripts where the Samba code is written is present in the op Samba flow in the apps directory. So this particular application is picking this script, but you do have a wrapper script to run this application based on the different configuration that you would like to run it on. So we have provided the scripts readily, which is attached to the GitHub here, but it is also present at data/data/anl scripts, and the script name is unit2d.sh. So this path, the /data/anl scripts, can be accessed from any one of the 8 compute nodes that you just saw. Once we get on to the terminal, I'll be showing that. So once we do that, the documentation also lists the different commands that you need for executing this unit application. So as a standard procedure, any of the applications first requires a compilation process, which generates the PEF file, which we have always been seeing in the last few sessions. And once the compile is done, when the PEF is generated, the PEF is supplied to this run script, and then you can perform the actual training on that application. So in this particular unit 2D, so the first argument that you will pass will be the command argument will be either whether you want to compile or run. So the first, you would initiate a compile command followed by a run. And the second and the third argument, the second argument actually will specify what is the image size that you want to run with. And then the third argument that you're passing is the batch size that you'll be running. And this particular configuration is going to just run one instance when you specify the total number of instances, because this is generated, the PEF is generated or compiled for a single instance run. And I will show you how you have to modify it when you want to run multiple instances. The same holds for the run as well. So just be aware that whatever compile you have arguments that you have provided here for the compile, if you want to run the same configuration and it has to pick up the PEF file that was generated from the first compile, then you need to provide your arguments similarly for the run command as well. Otherwise, it will not have a compatible compiled PEF that it can run. Of course, the last argument here is just, for your log, it can be anything that to specify a log directory. That is pretty much with the command arguments that you need to provide to run this unit script. We will go into the details of the script and see how it looks after this. But then another important aspect that you would want to know is when you initiate these scripts, where is the logging that is happening, because you want to see what's the progress of the application and so on and so forth. Having said that, so if you see the compile command in this particular script, you will have the compile script for which you are initiating these arguments. And you're saying that you want to compile. This is pretty much self-explanatory in the sense, what is the size of the image that you're trying to compile this model for? What is the batch size? And there are some specific SambaNova specific arguments that you can see where you want to enable convolution tiling. And you can see here that you are specifying the PEF name that will get generated as part of the compile process. And that is the same file name you would want to pass it to the run command. Another important aspect that you would probably want to realize is that this particular application, which is the unit 2D, requires only 4 tiles to compile and run. So, and this is a single instance one, and so it's essentially just number of tiles equal to 4 also means that it's just using half an RDU instance to run this particular application. By default, number of tiles is set to 8, which means it'll go and utilize the entire RDU. So yeah, please be mindful of the total number of tiles that you're passing. And of course, you can also pass the output directory to where you want your log to be defined. So that is with the compile command. And you can also see that you initiate the run command using the srun, because you use the slurm here for as a workload manager, which just means that when one user is initiating a run, it does not collide with somebody else. So yeah, you can get an exclusive access of the system at that particular point of time. And you can see that hook.py is the actual script that is getting initiated, and you are using the run command to initiate this training. And then pretty much most of them are self-explanatory with any of the unit models that, if you will be aware of these epochs or batch size and so on, based on the type of model that you'll be using. So which now brings to the fact that here I am. Uh, Let me clear my screen and hopefully you're able to see it. So yeah, I am on R1H1, which is not what I would ideally want. But if I initiate an SQ here, this will show what are the different jobs that are actually already running on the different hosts and racks. So currently, it's just me who's been running something. So we are good to go. So the first um, the unit uh, script is also present, as I told you, in the slash data in scripts directory. So this is the powerhouse of all the different models that we have support on the SambaNova. There are much more, but these are some things that the SambaNova team has helped us put together, and we can have a diverse range of models that you can use and train. Of course, you can tweak these scripts to change your configuration or have your own data setup and use that data to train, or you can even come up with your own model, custom model, and use that. And based on your needs, you can tweak them and run the model accordingly. So here you also have the unit 2D .sh that I just spoke. It's pretty much the same. The compile, you have different options where you can use the compile and run command for compiling and running a single instance um, run for unit. And pcompile and prun is a special case where you want multiple instances running parallelly, which is essentially a data parallel run across the different RDUs, or even it can be across different nodes or racks. So yeah, this just picks up the different arguments that we already spoke about. And we have the output path, which is essential to see what's the progress of your run. And essentially, we are going to use the brain MRI images that are open sourced in Kaggle. So that is the data set we will be using here. But again, you can always download your own custom data set and change it accordingly. Again, I'd like to reiterate that there are different um, virtual environments that are already created by the SambaNova team. So if you go through the apps directory, which is essentially the crux of running any model on SambaNova, so this, if you list the different VMVs that you can find there, you will have similar or a pre-built environments present under each of the different apps folders. So you can use them readily. And if you want to, by any chance, install any other application or packages on top of it, you can always use pip to do so. But then it's always advisable to first use the pre-built environment provided by SambaNova. So again, if you see the scripts here, there will be a compile command. So we already went through this compile command from the documentation. But yeah, that's pretty much what you would first initiate, a compile. And then the difference also between the single instance and parallel instance or multiple instance is that in the compile command, if you want a data parallel to be present, then you need to introduce the data parallel argument and a world size equal to 2 as part of your compile command. So here we will be going through only the single instance run, but again, please feel free to run all the other examples that you have in these directories at your leisure. And please do, report if you are running into any issues or if you have any questions. So that is with a compile command, and then it'll be followed with a run command, which we also went through. So that is specifically with respect to the single instance run. And if you want to run the prun, which is a parallel instance of running the model, we will be using the spatch command, wherein you have the arguments to actually initiate this script, which is just the run script. And based on the number of nodes that you want to, scale it, here it's scaling on one node, which means that it was already using only 4 tiles, which is like half an RDU to run this particular example. And now if you want to scale it out, when you're scaling it for one node, which means you have essentially 16 instances of data parallel processes of this application running. So please be mindful of all these arguments. I'm pretty sure Jimmy will go through them in detail in the next session. But yeah, if you have any questions, again, please do ask in the chat or contact us when you run into the issue. So another important aspect is, I know Jimmy covered it, please do not run any of the scripts directly from the /data in a scripts directory. I would recommend either using the scratch directory, or sometimes I use, my home directory to have all these scripts. Yeah, essentially, please do run it on your home directory, and please avoid using any of the common directories here. One of the reasons that you might not have access, right access to any of these directories. So please be mindful of that. So just for an example, I know we covered everything in theoretically and went through all the scripts. But if you just want to run the unit example, here you can always so you can use this command and then run it locally. But I have just tweaked here some of the steps just to ensure that I use a pre-compiled PEF. Yeah, it's as simple as providing all your arguments and a log path, and then just initiate, and you can see that the commands that are kind of being run here, and you can always see the output that will be present. So yeah, this is your output directory. So this is where exactly your PEF will be stored. Of course, you can change this. So currently this is in my home directory, but please feel free to change it to any data scratch directory, especially if your models are very large. And then you can see the progress or the logging of your run. And that would be here, that this will be using this particular log file. So if I am actually using this, you will see that the compilation has started, and then it'll go through. But I have, for the interest of time, I have already pre-run these models. So we can just go through the logs for the unit. Bear with me. So if you want to look at the compile log, so yeah. So this just starts off with all the compile command, and you have a bunch of things that you probably would want to skip. And essentially, you just would be looking at where the PEF file is actually generated. And this provides you the path for the PEF file, and which means the compilation is now successful. And for the run script, so assuming that now the compilation is succeeded, and then you want to look at so the run command here is what we already saw earlier, and this is the PEF file that we are passing it. And then if you come down and see that here, you can see that these are the logs that are just reading the data set over here. And then you can see the progress of the training that took place. Back. Okay. And then, yeah, you can, sometimes you do have, yeah. So there are a couple of print statements you can make use of to reason out or evaluate the performance. And here you can see that there is the throughput that you're getting with running just one single instance here. So that's pretty much how you would, follow to run any model, or at least the unit model here, and then try to navigate through the logs for this model. Let me check if there are any questions. And I'm hoping that Bill, and I'm pretty sure Bill and Murli will be taking care of it. So for Alfred, yeah, most of the scripts do run, but again, it depends on where you're trying to run it. So we always encourage you to use your home directory or the Scratch directory, and ensure that you have right access to the paths to where you are writing the logging or the compile directory to which it is directed to. So please be mindful of that. So Bill, could you just cancel your cron jobs? That'll be helpful. So again, you can always, so when the compilation is happening on the system, you will not see that job, as it's still not part of the Slurm job. So only once the compilation is completed, and then your training is actually kickstarted, then you can see your jobs queued up in the SQ command. And then you can, just as a quick example, you can see that one of my job is running, and there is another job that is pending from another user, because all the nodes are not available. So that is something that's probably useful to know when you're navigating through the cluster. So that brings, with our unit model, we can also run, so as part of the image models or the vision models, I know VIT has a lot of traction in today's AI world. So let's try to look what we see in the VIT compile script. Of course, all these scripts are present again in the /data ANL directory. So if you see here again, you're specifying the model name. Of course, it's based. You can always change that. Then you're providing that your output path, and you are activating the virtual environment that was specifically built for VIT. And again, please be mindful of setting the right environment variables, especially for bigger and larger models when you're training them. And here the output directory is now using the /data scratch and your username. Again, so as part of the compile and the run structure, you can see here that this is the compile command that will be used for the VIT. Again, this is the actual script that will be initiated, which is the opt samba flow apps image VIT hook.py. And you want to compile. Again, these are the arguments which are pretty much self-explanatory to any of the VIT models. So here the model is specifically using the VIT base model. I'm pretty sure the large and huge model are also available, and just tweaking this parameter would allow you to use the bigger and the larger models. Of course, you have the different image sizes, the channel, the path size, and these are pretty much specific to the model. And mind you, please use the Adam W optimizer. Adam does not work on SambaNova. So, and another, as I mentioned about the data parallel instances, this particular compile is for ensuring that you can run the VIT instance parallelly on different tiles and different RDUs. So you have the data parallel commands inserted into the compile. And then you have the PEF name that you want to provide in the output folder. So this is a compile command, which then will be, once the compile is complete, you will run your actual training, which again, please be mindful of using these Slurm commands to launch your training. Here it's using the sbatch, but you can also use the srun accordingly. Again, this is using one whole RDU for running the model. So you can maximum have like n tasks per node. And you're actually initiating the 8 different tasks on the, and so you're scaling out on the entire node. Please be aware of the CPU per task and provide it as necessary. And then this will just initiate the run script. And if you just go through the run script, here we will come back and see the command for the VIT. This pretty much a lot of, so the data directory is here. I think this uses the ImageNet data that's available on open, and then it will be training on that particular data set, and rest of the arguments are pretty much self-explanatory with things like the number of epochs, and if you want to change that, or you want to change the logging frequency, you can tweak these parameters based on your requirement. And that pretty much covers the VIT model. So again, never run the VIT run specifically, even though you have compiled it already. if you provide the pre-compiled path, which is present here in the VIT compile, which is the out directory. Oh dear. Yeah, so here, so if it's already present in the out directory, then it will not recompile. That has been removed here, so it will not recompile again. Again, if you want to use the same um, arguments that, and nothing has changed in the compile command, then you don't have to recompile it every single time. But if something changes with the parameters that you're providing for the compile, then of course you would, like for example, you change the batch size or the path size here or the image size, then definitely you would want to recompile for the new configuration. And another important point that I would want to stress is, since if you're trying during the training and you do not, so compile times sometimes may be larger based on the type of model, and the larger the model, of course, the compilation times are longer. So if you want to use a pre-compiled artifact, some of them are here present at /AML, and probably unit precompile if you want to use the unit, or you have the VIT precompiled artifacts in this directory. So if you want to use them, you can directly pass it in this output out dir instead of the data scratch username. You can also use that particular path that is already has the precompiled artifacts, so that you can just start your training without any compile. So for the VIT compile, there's pretty much no arguments that you need to pass. It can just pick up directly from the scripts that's already written. So you can see here that the compilation was already completed, but the logs are present here. So if I look at this log, you can see that it did not go through the compilation process because I already had the compilation artifacts present in that directory. But I will show you how the compile a log file also looks like. So here you can see that after the, since the compile was already available, it just ran the run command and then it submitted the job. So which means that if you see here under the SQ, you will see that the command or the VIT is now being run under this job ID. So if I see, so if you just check what the log file it's using, you can see that it's under this particular path. So you can always tail this. So the training is already started because the compile was available. But first, let me show the log file that is for the compile. So assuming there's no compile artifacts, obviously you will, your log file, okay, this does not have either. Okay, let me get to that next. But if you look at the outrun here, so this is the run command, then you will see that the training here is started. Pretty much self-explanatory with the logging that it's you will find the step number, the accuracy for each step, and then you have the loss and times per step, and so on and so forth. But I can also see the compile log. Hopefully, I will have it on the system. Okay. Yeah, so this is the compile command. And then it will be compiling with all its might. And I think the most important aspect of that, that it'll give you the PEF path that it would be created. This is under my data scratch directory. So that's pretty much what, of course, you can in detail go through the different logging for the compile, but the overarching goal here is to ensure that you know the right path of the PEF that was generated. So that is pretty much what we will be running for VIT. I don't remember if I did specify that for the VIT run, we are using the ImageNet, which is under this directory. Of course, if you want to replace that with your own custom data set, please feel free to do so. Which brings, I think we have probably time for just like one more model. And that's, I just wanted to show you a flavor of model box. So here we have the script for 7 billion llama, and that is for fine tuning. So if you go through the setup, pretty much similar to what you would see in any other script. So this is using two arguments here. The first one is the number of nodes you want to scale it on. And the second is just the log directory that you would want to specify. Of course, you are now familiar with all the output paths and the output directories where the PEF file will be generated. And then again, so this is a model box, which the PEF is already generated by the process that it uses the Singularity container. Here we'll go through the run model box here script, but essentially it is scaling on the number of nodes equal to 1, and the total number of tasks, I think, is 16 here. And then, the CPUs per tasks, and accordingly, and this will launch this particular script here. Again, you can always change the output directory to use the if you want to use any precompiled, but that's pretty much you want to know from that script. And if you come through the run script, of course, this is where you specify the checkpoint path. And this is using the Llama 7 billion HF, but with the BF16 data path, and the data path, it's using a super glue 4K1K for the fine-tuning process. Of course, you can change this accordingly. And then you provide these and bind these paths for the singularity arguments, and which is followed by pretty much the arguments for the model specific, and some SambaNova specific for its hardware. So it's pretty much self-explanatory, and you can just run the 7 billion fine-tuning setup and not the run directly. And I would probably just use one node, and then you can always give, let me command here. And then you just run it, and you see that this is using just one node, and then this is the output file that you want to see the progress under, and the job ID or the Slurm job ID is specified here. And you can see now in SQ, this will have started running. And if you want to tail using this particular log path, you will see that the training will follow. But I think I have the 7 billion model box already run. So let's just go through the log file. So this pretty much, has the run command. You will see the run command over here. And then these are some of, and then some things are initialized on the hardware. And then you can see that it starts to train from here. So yeah, you can see the progress over here with epochs. Of course, there are a lot more steps that, and this is just showing until the 26 out of the 3,000, around 400 plus steps. And the logging is pretty self-explanatory with the different step and the loss values and the validation values and evaluation accuracy as well. So yeah, that's pretty much what I had to cover. But again, I cannot stress enough that you have all the scripts here under the data/ANL scripts. So please feel free to use it, try them, and then if you're running into any you have any questions, or you're running into any errors, please contact us so that we can have it fixed.